We're proud to announce CISO Stories, a new podcast series in partnership with Cybersecurity Collaborative and Cybereason. CISO Stories features the candid perspectives and experiences of frontline senior security executives and dives deep into timely security topics. CISO Stories is hosted by Todd Fitzgerald, VP of Cybersecurity Strategy at Cybersecurity Collaborative, and Sam Curry, Chief Product and Security Officer at Cybereason. Listen weekly as they speak with extraordinary CISOs by visiting securityweekly.com/CSP.
Welcome back, everyone, to Paul's Security Weekly. Quick announcement before we get started. CRA's Business Intelligence Unit has launched its next survey on Zero Trust. What are your barriers to Zero Trust implementation? Take our survey and enter to win a $500 Tango card by visiting securityweekly.com/Zero Trust. Report results will be released at our upcoming Zero Trust eSummit in March. WHEEL is a member of the WHEEL group, as WHEEL is an acronym or throwback to BSD, I believe, and so we get a different WHEEL this time around, representing the Qualys research team responsible for finding zero-day vulnerabilities or vulnerabilities in general. WHEEL will discuss the recent discovery of a older 12-year-old Linux vulnerability in PolicyKit, which Qualys has dubbed Pwnkit. We'll provide an overview of the vulnerability, and we'll dive into some frequently asked questions and some technical discussion. WHEEL, welcome to the show.
Hi, Paul, and hi, everyone.
It's nice to have you here. I guess, first, we should probably talk about the difference between PolicyKit and Pwnkit, right? Because Pwnkit, P-O-L-K-I-T, is the newer version of PolicyKit, correct?
Yes. Yes. Go ahead.
I was just going to, does the vulnerability impact just the kind of newer Pwnkit replacement for PolicyKit?
Well, the vulnerability itself is in a specific utility within Pwnkit, which is PKExec, and you don't have Pwnkit properly configured for this vulnerability to be exploitable, because you just need to reach the SUID binary, which is PKExec.
I gotcha. And this exists in quite a few Linux distributions. Is that correct?
Yes. Nearly or major Linux distribution has PKExec, and it is vulnerable since its creation in 2009. So it is really widespread.
And this is usually installed by default in most distributions, correct?
Yes, it is in major distributions. It is nearly installed by default in all of them, nearly all of them.
Typically, though, not in containers. It's interesting, when I was looking to set up a lab to test this vulnerability, I spun up an older Debian container. I think it was Debian 8. Jessie is no longer maintained, and that version of Pwnkit that I installed in there was in fact vulnerable and served as the example for this.
Well, there might be some versions in which PKExec is not available, and I actually don't know which of them exactly. But yes, but we know that in nearly all of them, PKExec is there by default.
And WHEEL, what is the intended use case for Pwnkit?
Pwnkit allows you to communicate with privileged processes for unprivileged users. Specifically, PKExec allows you to run commands as another users in a similar way sudo does. And yeah, it is similar to how sudo works.
I'm told it's like the sudo for systemd. Essentially, it's usually background processes, right?
Yes.
And so I guess it was that nature, right, of the various ways in Linux in which you can elevate privileges and the guardrails around those that probably made this attractive, right? I guess first that every Linux, or not every, but most Linux distributions include it. And it is a facility similar to sudo for escalating privileges that turns you and your research team to start looking at the code.
Yes, not only having much more ways to escalate privilege, it is more attack surface, but also the complexity itself for this program made it exploitable, actually, because the main problem on this vulnerability is that the code is really complex because, well, not the code, but the external library it used. So it made the Spark be exploitable in the way we used.
Yeah, I was trying to read some of the source code. It wasn't very straightforward. It looked like there was a lot going on inside the code. The logic, in other words.
Yes, the main problem is that it uses external libraries that are complex in what it does, especially the gprinter function. And this made the trick of introducing a dangerous environment variable possible. And this is what made this bug exploitable to achieve root privilege.
Mm. Were you aware of other research into this project, or did that come out after?
No, we found this vulnerability by auditing the source code of PKXec. But after the release of these of the advisory, we found out that someone on Twitter said that he documented something about ARGC equal to 0 and PKXec, but we did not know about this in previously to the advisory.
Gotcha. Yeah, that was Ryan Mallon. It's interesting. Ryan's post points to some of the exact same source code that his post actually was called argv silliness. What is the argv kind of component to this vulnerability? Because that was part of it, right?
Yes, the main problem on this vulnerability is that the programmers assumed that ARGC would not be 0. So an index of 1 in ARGB would be actually accessing the null pointer terminator on ARGB. So if an index of 1 is accessed when ARGC is 0, you are actually accessing an out-of-bounds index, which corresponds to the environment variables, NFP. So that's the main problem. So it is actually a memory corruption and out-of-bounds, right?
Right, because that it's counting the arguments, right? So the program that you're executing is argc, the first position in that array, and then the argv is the count. Did I get that right, or is it the other way around?
Yes, the ARGB is actually where you are accessing, but as the index is out of bounds, you are actually writing to the NFP 0. So this allows you, after some manipulating with a function that tries to find the binary using the path environment variable. And this allows you, after some movements on the string, to introduce a new environment variable, which can be one of the dangerous one that LD does so removes on program initialization. And this is what a primitive we use to exploit this bug.
How would you classify this bug wheel?
Well, it is memory corruption, like any other. You're writing past the end of an array, so it is actually a memory corruption. So, but we are using a data-only attack to exploit it, which is we're not using any control flow technique like ROP or ejacking pointers. We are just modifying data. So this makes the exploitation really reliable and in an architecture independent way. So this is what makes this vulnerability really exploitable and reliable. And this is what is really dangerous about it.
Yeah. Yeah, I noticed that when I ran it, it was super reliable, super fast, and like you just escalated privileges, and it didn't even bat an eye. And that's because of the memory corruption. You're able to manipulate things directly rather than relying on pointers and bouncing around inside of memory to gain execution. Correct?
Yes, because on some memory corruption exploits, you rely on specific heap conditions. So you perform some heap rooming that changes between different versions or
Mhm.
configuration. And on this case, you just have to overwrite data, and it ends up being really reliable. And also, as you're not using any ROP gadgets or you don't need any pointer or predictable addresses. You just don't rely on specific offsets for program versions, so it is actually what makes it pretty reliable.
Mm. And it's interesting, that there was a researcher that was kind of poking around this at first, and then you and your team kind of poked around in it and developed an exploit. Do you feel like we need to have a proof of concept exploit before the open source developers really, or really any developer, kind of takes it seriously to apply a fix?
Yes, because probably this bug could have not taken seriously if there would be no proof of concept exploit. Because apparently this bug is like the typical bug that sounds like non-exploitable.
Mm.
But the complexity of using glib made it exploitable. So I think it changed a lot by using an exploit, a proof of concept exploit that demonstrates the severity of the vulnerability.
Do you think there's other conditions like this in open source software that leads to this kind of more not easily exploitable but more reliable exploitation in this way?
Yes, and after all recently memory corruption protections, usually what researchers try to find on exploitation techniques is data-only attacks, which are what make the exploit more reliable, and that allows you to bypass most of the memory corruption protection techniques. So yes, an exploit developer will always try to find a data-only attack to make the exploit more reliable.
What are some of the mitigations for this particular vulnerability?
There's some specific mitigation, which is ARM-MTE, which would probably detect the out-of-bounds access. But most memory corruption protections rely on control flow hijacking, like Intel SAT or any other like ASLR, which prevents you from knowing addresses because of randomization. Or most of the techniques are attacking the control flow hijacking, and this is what usually exploit developers try to prevent.
And simply removing the SUID bit is also a temporary mitigation.
Yes, it is a temporary mitigation if you're not using PKExec, because the use of PKExec relies on the SUID bit. In fact, if you execute PKExec without the SUID bit, it prints out an error. But yes, if you're not using PKExec and you cannot patch, then you should definitely disable its SUID bit to prevent exploitation attempts against it.
That could have other repercussions, though, right? How would you know if something was using PKExec?
Can you repeat the question?
What could that break if you remove the SUID bit from PKExec? Right, you'd have to know other processes that are calling it or using it.
Well, I have right now no idea about which processes use pkexec, but well, it should not work if you remove the side bit. So yes, if a process relies on pkexec, it would probably grow, but I have no notice of any major process that uses it.
Mm. Yeah, so that's kind of an unknown. So best to apply the patch in this case. Did you folks help develop the patch, or was that left to the project maintainers?
Well, both. It was left to the project maintainers, but it was checked with us to make sure it is fine, and it is not introducing any other vulnerability and solving the one in particular.
Do you know who maintains the code for this particular for Pwnkit? Is it a group of volunteers or?
I personally do not.
They were pretty responsive though, it seems like.
We, in the responsible disclosure, we had no direct access with them because we did it through Red Hat security product.
Mm-hmm. Okay, I gotcha. And this is only a local attack, right? It's not remotely exploitable. You have to already be on the system, obviously, to exploit this.
Yes, you need execution context within any user in the local machine. But you can exploit this bug always that you have access to pkexec. So, for example, if you have access to pkexec from the nobody user, you can exploit it. So you don't need to be in any specific group or something. So you just need to have access to pkexec to trigger this bug.
And it seems like the patch is pretty innocuous, right? Like I don't see where people would be really hesitant to apply this patch because of any other kind of risk.
Yes, the patch just checks for ARGC that is equal to 1 or more, and just prevents ARGC equal to 0. And if ARGC is less than 1, it exists. So the patch is really simple.
And it says in your post that this technique actually leaves a trace in the logs when it is successfully exploited. How and why
Yes.
is that?
Because there's a function within pkexec, which is log message, that sees logs on specific conditions. But with a race condition, you can prevent this log messages being logged to syslog. So this can be used in any exploit to prevent logging to syslog, and you could avoid any traces.
I see. So you have to put in your exploit to basically exploit that race condition so the log doesn't get written.
Yes.
Or clean up after yourself after exploitation, because you're root on the system after that.
Yes, but if you have any process probably monitoring, the process could detect the exploitation attempt. So it is better to maybe do the race condition trick, so you can prevent any logging.
And did you provide the a working exploit to the folks over at Red Hat when you disclosed this vulnerability?
Yes, we usually provide exploits, but we do not publish them usually because we want to leave some window of time until exploits are published. And as we know that proof of concepts are going to be public soon by other researchers, we usually don't publish proof of concept.
Yeah, that's always the trick, right? Like I feel like as soon as the the patch is pushed to that particular project, like that starts the clock ticking for people to review that and start developing exploits.
Yes, and on this specific case, this memory corruption is easily triggerable, and we knew already that researchers will public proof of concept exploit, so we already knew that.
Yeah, they definitely exist on there, and they definitely work really well.
Yes.
In my own testing. Do you kind of save up like what you've learned from each one of these exercises in finding these vulnerabilities? I'm assuming you apply that to future research. Like, how easy or difficult is it to, understand this vulnerability and then start applying that to other projects in the open source community that may have similar bugs?
Well, on this specific case, the main exploitation process is the use of those dangerous environment variables. So maybe if any other project that allows you a similar primitive within vulnerability and uses the gconf path somehow with icon B, then it is possibly exploitable with the same technique.
Yeah, but you're still at that point looking for needles and stacks of needles in all the open source code that's out there, correct?
Yes.
It's amazing to me how long some of these vulnerabilities can go undetected. This one was 12 years old, and we've kind of seen a history of, these highly exploitable bugs in these projects. Any tips for the open source developers in the community to maybe discover and/or squash some of these bugs on their own, or are we heavily relying on folks like you and your team to uncover some of these vulnerabilities?
When software is really complex and there are a lot of type of vulnerabilities, and usually, researchers are the ones that discover those vulnerabilities, and also developers. But yes, and tips for developers on this specific vulnerability. This vulnerability relies on argc equal to 0, which is an assumption a programmer can make that argc can be higher than 0. So programmers should always take into account that argc can be equal to 0. So it can be something that leads to bugs sometimes.
Yeah, I did. I remember reading that in some of the articles about that. It was about those assumptions in argc that really, and people were kind of perplexed as to why that was there. Why those conditions were even available to have argc, be more than 0.
Well, I'm not sure. In the case of OpenBSD, it was disabled, so you cannot use execb against binary with argc of 0. And right now on the kernel, it is being discussed if disabling this behavior. So, but I'm not. I do not know about the exact reason this is enabled.
Yeah, I feel like that's an open source thing, right? People build features in, maybe not necessarily for an existing use case, but maybe a future use case, and they leave things a little open that opens up, these types of security bugs.
Yes, and probably it hasn't been disabled maybe for backsquare compatibility. So yes, it is that.
So, but this particular issue you said is being fixed in the kernel, in the Linux kernel?
Yes, it is being discussed if disabling it, and if so, how. All points do it being disabled with returning inval from the syscall.
Well, that's pretty awesome. I love that you folks are making the the whole world a safer place, right? By pushing some of these ideas and thoughts, all the way upstream into the kernel, so that we can prevent, at least this type of bug. Of course, there's lots of other bugs for you and your team and all of us to find in open source software.
Yes, exactly.
Any insights as to what you and your team might be looking at next, or tips for other people that may want to also continue discovering bugs in open source software?
Well, we usually just read code, and we audit just by reading code. But there are a lot of other ways to discover bugs, like, for example, fuzzing. So it is just read code, know what types of vulnerabilities are right there, and once you identify a specific project, you can try to think of possible vulnerabilities it can have, like privilege issues or memory corruptions, and then read the code and always be thinking different ways you can try to trigger a vulnerability or try to find bugs.
Yeah, it's interesting. I feel like there's a certain mindset of creativity and threat modeling that has to happen, coupled with some deep technical knowledge to be able to read the code and kind of apply those theories to the code, which I think limits this type of bug hunting to a subset of people like yourself out there.
Yes, something really important is be creative and be really observant. And every line of code, try to find if there is a way you can turn it into a possible bug or something you can gain from an attacker's point of view. So yes, is read the code and try to be creative into possible ways you can use that as a bug.
Yeah, I also think Will, there's a certain amount of persistence too. That like, oh, there might be something here, but I'm just missing something, or vulnerabilities you got to chain together to get full exploitation.
Yes.
So don't give up.
Usually,
don't give up too easily.
yes. Well, some vulnerabilities are clearly not exploitable because you actually see that there is no way you can continue, and they are just bugs, for example. But in others, sometimes it is really difficult to exploit them, but possible. And yeah, it clearly depends on which vulnerability. But sometimes there's always a way you can transform it into something useful for an attacker's point of view.
Yeah, and for reference for our audience, Wheel, how long did it take, from start to finish to detect and exploit this particular vulnerability?
Well, we started like capture the flag challenge, like playing, in which we tried to find as many vulnerabilities in SWID by default in programs. So we eventually found this bug, and we lost like a month between the discovery and the full exploitation of this bug for root privilege. So yes, approximately a month.
And so when you say you set up a capture the flag, was that like internally in your team, you set out to find SUID binaries and see where there might be potential vulnerabilities that are exploitable?
Yes, exactly. We started to audit code and SUID binaries by default, and eventually found this bug.
And even after that, it took you and your team a month.
Sorry, repeat.
And so, once you identified kind of the initial issue, it took your team a month to come up with a working exploit.
One month from, well, no, it was a month from the starting of the audit on PKXX
Gotcha.
until the discovery of that bug
Gotcha.
and the exploitation of it.
And so you also, for folks out there, you probably went down a lot of other roads that didn't, have any vulnerabilities that were exploitable as well. So there's a lot of
Yes.
a lot of dead ends, in other words, right?
Yes.
Well, Will, we thank you for your work and continued work in making open source software more secure and really moving the needle in terms of security in open source software. It's really great work.
Thanks.
Anything else you want to share, Will, about this vulnerability and or the process?
You should definitely patch, because this is a really serious vulnerability and is pretty reliable. And if you have that PKX vulnerable, an attacker is really likely to exploit it successfully. So it is a really serious vulnerability that everyone should be careful about. And just that.
Awesome. Yep. Get out there and patch. Will, thank you so much for appearing on PolicyKit Weekly.
Thank you.
And with that, we will conclude the show for this evening. Thanks to everyone for listening and watching. Over and out.